Hello, it's Miss Lulu again with part 2 of the properties of exponents. Continuing on with Unit 4, Target 1, where we are expanding and condensing expressions and still learning our properties of exponents. In Property 2, we're going to be learning of the product of powers. But first, let's fully expand the expression x to the 4th times x to the 8th. So what does that look like? That means that we have 4 copies of x from our x to the 4th times 8 copies of x from our x to the 8th. These are all being multiplied together. Now, after we expand this, we're going to condense the product into a monomial. Remember, that means one term with exactly one base and one exponent. Well, our base is the same for, even though we're multiplying two different parts here, our base is going to be an x. Now, how many x's do we have total between this fully expanded expression? We have 12 x's total. This leads us to property number 2, the product of powers, which states that if we have a base raised to a power multiplied by the same base raised to a power, then we can keep the base the same, and all we do is we add the exponents. So let's look at some examples. In number 1, we have a cubed times a to the 4th times a squared. They all have the same base of a, so that means when we combine our powers, they will have the base a. So we are going to take a cubed times a to the 4th times a squared, and we're going to add those exponents, 3 plus 4 plus 2, which becomes a to the 9th. In our second example, we have 2 different bases. We have our y's and we have w's. In our y's, we have a y to the 5th and y to the 6th. So since those both have a base of y, we're going to be adding 5 plus 6. Our base of w will just remain with its w squared because it doesn't have another base of w to combine its exponents with. So y to the 5 plus 6 is y to the 11th, w squared. In the problem to the right is a you try now, which means that I'd like for you guys to try this one on your own. So, using the product of powers property, try condensing this expression into a monomial. If you notice on the right-hand side in your listening notes, the answer is listed there so that you can check your answers. Make sure to write down any questions that you have that we can go over in class tomorrow. Our next property is a combination of 3 different types of properties: the power of a power, the power of a product, and the power of a quotient. Let's start by investigating these properties. In our first example, we're going to fully expand x cubed raised to the 4th power. So what does that mean? Remember in our first video of properties of exponents, when we have a base being raised to a power inside parentheses, that actually this x to the cubed acts as the base. So we have 4 copies of x cubed. Let's write that out. X cubed, that's the first, times x cubed the second, x cubed the third, and x cubed to the 4th. So we have 4 copies of x cubed. Well, how many copies of x is that total? So we have our first 3 times the next 3 times the next 3 times the last 3. So when we expand this expression out fully, we end up having 12 different copies of x. So that is our condensed expression into a monomial with exactly one base, which is x, and our exponent of 12. In our next example, 2x squared y, 2x squared y is going to be our base being raised to the 3rd power. Let's expand. 2x squared y our first, times 2x squared y the second, and 2x squared y the third. Now we need to condense this product into a monomial so there's only one of each type of base with one exponent. So before I do that, I'm going to rewrite this in order and group all of my like bases together. So I have 3 2's being multiplied. I have 3 groups of x squared, and I have 3 copies of y. So how many of each of these is there total? Well, we have 2 times 2 times 2, which is 8. And as we learned from our property number 2, when we have the same base, our same base of x, with exponents being raised to a power, we add these exponents. So this is x to the 2 plus 2 plus 2, which is 6. And we have 3 y's. So we have 8x to the 6 y cubed. Are you guys starting to see a pattern? Let's try the next one. So we have x squared y cubed as our base being raised to the third power. Let's expand. X squared over y cubed, that's our first copy, times x squared over y cubed, our second, and x squared over y cubed, the third. We're going to multiply straight across as we would as multiplying fractions. So we have x squared times x squared times x squared over y cubed times y cubed times y cubed. Again, using the property we learned last, property 2, we're going to add these exponents. So we have x to the 6th and y over y to the 9th. So what do all of these properties have in common? Well, it turns out that when you are raising a power on the inside to a power on the outside, that we end up multiplying the exponents. Let's see what this looks like as a general case. Originally, if we have x to the a on the inside acting as a base being raised to the power of b on the outside, we would take x to the a times b, and we multiply those two exponents together. We also use multiplication if we were to have a case where we're multiplying two products together, being again raised to a power on the outside. So we have two separate bases here, x and y, both being raised to a power, and then this acts as a base being raised to the power of b on the outside. So what we're going to do is we're going to take our base of x and raise our power of a to a times b. Our base of y also gets multiplied, our exponent of a gets multiplied to be a times b. And one last case is when we have our quotient of powers, x to the a divided by y to the a, all raised to the power of b. So we have two different bases, x and y, both being raised to a power on the outside. Just like the last two properties, we're going to multiply our power on the inside by the power on the outside. So this becomes x to the a times b over y to the a times b. Let's do some examples. In our first example, we have b cubed on the inside being raised to the 8th power on the outside. Since we have a power being raised to a power, we're going to multiply these exponents. B cubed times 8 becomes b to the 24th power. In example number 2, 3 is acting as a base, not as a coefficient. The base of 3 is raised to the power of 4. So, using our property, we have 3 to the 4 times 3, which becomes 3 to the 12th. Since 3 is a numerical base, we can evaluate 3 to the 12th, which is 531,441. In example 3, we have a product of powers, a, b, raised to the third power. So, how are we going to multiply when the a or the b aren't being raised to a power necessarily? Well, they are being raised to a power. It's just one that we don't see, 1. So, a to the first power times 3 times b to the first power times 3 becomes a cubed, b cubed. In example 4, we have a coefficient of 7, which also has a power of 1. So this power of 1 is going to be multiplied by 4. And d to the 5th power will also be multiplied by the outside power of 4. So we have 7 to the 4th times d to the 20th. Since 7 to the 4th is a numerical answer, we can evaluate that to be 2,401 d to the 20th. Our last two examples involve our quotient of powers. We have 8 to the 1st on the inside, so we'll multiply our 8 to the 1st times 3 over 5 to the 1st times 3. which now becomes a cubed over 5 cubed. We can fully evaluate 5 cubed to be a cubed over 125. In our last example, we have x cubed being raised to the third power over 2 to the first power, which also gets multiplied by 3, y to the second power multiplied by 3. So we have x to the 9th on top, 2 cubed, y to the 6th on the bottom. We can evaluate that 2 cubed, so now we have x to the 9th over 8, y to the 6th. There are 3 you tries on your right, as you can see on the right side of the page, so I'd like for you guys to pause the video and to try those problems on your own. Answers are in the listening notes section on the right side of the page. Make sure you guys write down any questions that you have, and we'll go over those in class tomorrow.